Hi, Mr. Masura here. I'm here to explain the video that I included in the notes regarding destructive interference. Now, interference happens whenever two waves meet and their effects overlap. Destructive interference happens when the waves are trying to do opposite things and they partially or completely cancel each other out. After all, waves can work with each other, that's constructive interference, or they can work against each other, destructive interference. So let's take a look at this video. In this video, we have two students, one on each side of this long spring, and they're going to make waves in the opposite direction from each other. So let's pause the video right here. On the right side of the spring, you have a wave going up. On the left side, you have a wave going down. And you notice both of these waves are roughly the same amplitude. So when these waves meet, the first wave tries to get the spring to go up, and the second wave tries to get the spring to go down by the same amount. And when that happens, they completely destructively interfere with each other and cancel each other out. In fact, if I play this right about here, you notice that at this one moment, both waves are in the same spot at the same time and are trying to do the exact opposite things. So, at this moment, the spring appears to be almost perfectly straight. That's destructive interference, when the waves cancel each other out. But it only happens while the waves are overlapping in the same spot, and it only happens when the waves are the same size as each other. If I continue this, the waves will continue moving and they'll pass through each other. So after we continue, now you can see the wave up is on the left. It continues moving as if it never bumped into anything at all. And likewise, the wave going down is now on the right side of the spring because it too continues moving as if it never bumped into anything at all. If we continue watching the video, you notice that both students have their hands held down firmly in place. That's a fixed point, which means when the waves reflect off of those students' hands, the waves will flip to the other side, because that's what waves do when they reflect off of a fixed end. So here we go. You can see both waves flipping to the other side. And once again, you've got a wave down and a wave up that are roughly the same amplitude. So when they meet, they should cancel each other out almost completely. That's that moment right here, where both waves almost completely cancel each other out. And once again, after the waves meet, they continue moving as if they never bumped into anything at all. So if I play this video, now the wave up has gone and passed and is now on the left side of the spring, and the wave down is on the right. So there's a couple things I want you to observe in this video. One is that waves can destructively interfere if they are trying to do opposite things. In this case, if the waves are the same size, the destructive interference will be complete. The waves will completely cancel each other out. And I also want you to realize that after the waves meet, they continue moving as if they'd never bumped into anything at all. And finally, in this video, you can see how when a wave reflects off of a fixed point, like when the boys hold their hands down firmly, it causes the wave to flip to the other side when the wave reflects.